Welcome to another Operator Framework SIG meeting, and had a little technical difficulty with the Hacker MD, so I'm improvising today with the using gist. So I'll add your names in as I can, and I have a tentative proposed agenda for the day, and the first thing that we were going to do was talk a little bit about the new operators and who the new additions are and what's in the pipeline and PR issues and PRs. And I was going to task Rob with talking about that. So Rob,
I'm going to do that, Diane.
Oh, I'm going to see you do this. You figure these things out without me. So Daniel, you want to share your screen and walk us through all the new additions?
For sure. Hopefully this time BlueJeans is able to just share a single window instead of the whole screen, because I have like a 34-inch monitor. So you should see just Google Slides now, hopefully.
Perfect, yeah.
Awesome, okay. All right, so for those of you who don't know me on the call, and those who see the recording later, I'm Daniel Messer. I'm a product manager in the OpenShift business unit here at Red Hat, and I'm looking over parts of the operator framework, specifically the SDK and the operator lifecycle manager. So also, as a little side project of mine, I do see and look after OperatorHub.io, which is our community registry for operators targeting the wider Kubernetes audience. And we've seen quite some traction actually since we've launched this. Just as of today, we actually crossed 50 operators on that particular website, which is pretty amazing. And we got a couple of interesting new additions, which I'm going to share with you here in a second. We are also going to talk about a couple of new features that we have already released on the site and that we are planning to publish in the next 1 or 2 months, which should hopefully make the process of packaging your operator, should you have already started to write one, or like updating your existing operator, much easier. Parts of the slide didn't load. Try reloading or show anyway. Sometimes Google doesn't like me. So yeah, no icons for us today. That's kind of weird. But that did totally look different in Google Slides when I edited it. But we can just take a look at the site itself, right? So we have a couple of new interesting additions from across the board. One or a couple of ones that I wanted to pick out, not all of them, is definitely Rook. Rook is like an overarching storage project on Kubernetes. So that's basically running your software-defined storage on Kubernetes itself. And there are multiple flavors, if you will. One of which is, and it's probably the most widely known so far, is Rook Ceph. So we've added Rook Ceph to OperatorHub.io. Has been packaged and has been tested with Operator Lifecycle Manager, Minikube, and various other Kubernetes flavors. And you also see next to it Rook HFS, which is another flavor of Rook. So Rook is just really a generic platform for managing distributed storage systems on the cluster, running as workloads on the cluster. And that's really cool because if you have attended KubeCon or you've seen some of the recordings of the keynote sessions, it was actually a gentleman from Google who was running a session where he debunked some myths around running storage on Kubernetes or running stateful workloads consuming storage on Kubernetes. And one of the statements that he put out there was that if you're going to run such a software-defined storage tier on the platform, you want to do it with an operator. So Rook squarely sits and fits in that vision, right? Of having all the logic that you are required to operate such a platform in a consistent and production-grade fashion has that built in. So for some who have maybe been around a little bit longer, you probably have heard around container native storage in the 3.4, 3.5 timeframe, where we had this like little component called Hekati that would usually sit outside or sometimes inside of the cluster and would do that storage provisioning for you, given that you had already set up in this case, cluster deployment, right? And that was basically what it did. It didn't quite look after the lifecycle of the cluster installation itself, so you still needed to know, how cluster works and, all the kinks and details around how to do that on Kubernetes. And OpenShift and Heketi would be there to basically provide an API for cluster. Now, Rook completes that picture in a much more holistic sense and basically provides storage lifecycle management and storage management on the platform. And it does it in a generic enough way so that it's not only Ceph who's able to make use of that, but also HFS, which is another highly efficient distributed storage layer on Kubernetes. We have another storage solution. You'll see storage is kind of a reoccurring theme here in there, which is Portworx, which has been out there for quite a while, but now they released their operator, and they've actually also tested it and certified it with OpenShift. And as part of that, they also provided an upstream version of that for plain Kubernetes usage. So Portworx, very similar to Rook Ceph, basically containerizes the storage engine itself, runs it in pods on Kubernetes, uses Kubernetes primitives to orchestrate that. It's based on a daemon set basically, and uses your Kubernetes host storage to provide a virtually shared and replicated pool across all the nodes of your cluster for consumption. Another thing that I wanted to point out is down here. It's a Spinnaker operator by OpsMX. There's actually an existing Spinnaker operator that's the OpsMX version that provides some added value and some additional features that you don't get with the vanilla distribution of Spinnaker itself. But Spinnaker is quite a popular CI/CD or specifically CD solution for Kubernetes because it has been written with Kubernetes in mind. So it's very easy to implement continuous delivery on the cluster with that. And with the operator, you now have the ability to run the Spinnaker operator on the cluster itself. And you don't need to be an expert on how to set up Spinnaker, which can be quite involved, especially given all the configuration options that you are allowed to choose from. You would just use the operator to do that, and you get a fully featured continuous delivery version, a continuous delivery solution on Kubernetes, which would allow you to do things like canary deployments and automated canary deployments. So pretty exciting. One thing we were particularly proud of because we worked together on this is the release of the Elastic Cloud operator on both OpenShift and Kubernetes. So you are now able to basically get your Elasticsearch and Kibana instances out as a matter of just creating another object. So the Elasticsearch operator is now on OperatorHub.io as well, is packaged and ready to go wherever Operator Lifecycle Manager is present. And there are some more exotic ones that I didn't even know existed before. So there is something called FFDL, which is an operator done by IBM, which is a fabric for deep learning. So that's something that I've been meaning to try for some time now, but it didn't quite find the slots in my agenda yet. But that looks very promising on how to orchestrate and install FFDL on Kubernetes. So that's like a collection of deep learning frameworks right there for you to leverage Kubernetes' ability to quickly schedule workloads and quickly scale out workloads as part of the model training and then also later on serving. One thing that was featured at KubeCon in its own session was actually Aqua Security. So if you ever wanted to do a little pen testing on your own cluster, so don't do this with your coworkers cluster or your production cluster, but if you wanted to do pen testing against your Kubernetes cluster and test it against a variety of known best practices and security precautions, you could do that. So Aqua basically gives you a set of tests that it will run against your cluster, and it will check for API availability, unsecured endpoints, unauthenticated endpoints, missing SSL encryption, all these kind of things. And it's available as an operator. And you can quickly install that on your cluster and get a report of which kind of security vulnerabilities or like missing best practices, so to say, were found on your cluster. So pretty exciting. I think the last one I wanted to quickly highlight was also Strimzi. Kafka, I think since we last spoke, it was already in the queue and was available on OpenShift, but not on Operator Hub. So Strimzi is an opinionated way to run Kafka clusters on Kubernetes or OpenShift. That operator basically gives you the plain vanilla Apache version available on your site or on your cluster. And as you can see, you can be pretty granular of the resources that you wanted to control, right? So even things like topics or users or connectors are exported and exposed by this operator, and allows you to run things like Kafka at scale, at the scale of your cluster. This is what I kind of wanted to highlight as stuff that has come in either recently or some time ago already. Fortunately, we have seen quite an amount of uptake in terms of the submissions. On the other hand, we weren't quite always able to process and review them in time, which is why we spent some effort actually on streamlining this particular process a little bit. So if you now open a pull request on your on operatorhub.io, you will actually get to see like a little checklist of things that you should consider and think about and check off before you kind of submit your PR. So these are basically general things of like reading our contribution guidelines, which we have now put in place, where we basically explain to you where to contribute what and how to package your operator, what that bundle format is all about, and what you need to put in there in order to make OLM happy. And then also what you contribute in which directory and what platform you're targeting with that. Right. And then we've also revamped our testing docs to give you like a very prescriptive and necessarily detailed way to test your operator, right? So whether you start on Kubernetes or on OpenShift, there are certain things you can do to make sure your submission is sane, your descriptions are good, and you have a working operator bundle. And then we provide you with step-by-step instructions of actually, even starting with a Minikube cluster, installing OLM, installing Marketplace, creating your operator source, assuming you have uploaded it to Quay before, and then use that to instantiate your operator, get it to a healthy CSV, and then check that your operator has been given the right amount of RBAC, the right amount of settings to do its meaningful work, right? So all of this is now probably and hopefully better documented.
Can I ask a quick question? This is Andre. So one thing we were discussing actually just this morning is what if there's just document changes? So what if we find a typo in the description or something, want to fix that real quick? I mean, would that run through very quickly? I guess because that wouldn't necessarily require a retest of any of the code because the code wouldn't actually change. It's just documentation.
Oh, for sure. Yeah, we would love for you to find PRs against any things that you find missing or like wrong there. So yeah, definitely this is by no means just owned by a couple of people. This is really out there for the community to embrace and to refine. So if you find stuff, just give us a PR. I look at the PR list daily. The Operator Tiger team looks at the PR list daily, and if you see a doc enhancement, that's very much low-hanging fruit usually. So yeah, by all means, keep those coming.
Okay.
And yeah, use this checklist if you want to submit or update your operator, just to be sure that you have done through all the things. We do all test. We test all this as part of the CI. So you might have seen some changes in the CI actually that is executing now much more tests. So you see here there's actually now, this is just a single test because this is an upstream community operator, but this includes Travis CI, which implements all these things from the checklist I've shown you before. For OpenShift operators, we have an even more rigorous set of checks in place that will basically, do the linting, make sure you're not colliding with any kind of operators that are already in the OpenShift catalog. They will deploy with OLM. They will check your metadata. They will check that you haven't modified more than one operator at a time. And as part of the new PR guidelines, we also ask you to basically not mix operator versions in your PR, nor mixing community versus upstream community, right? So that the CI gets a reasonable chance to basically test both, right, on the respective platforms. So community tests actually on OpenShift 4.1, and upstream community actually tests on Minikube, right? And we want you to basically submit your PR separately to enable us to do that properly, because it otherwise gets very hard to, write all the scripting logic to figure that out. One thing we've actually added to the site itself to help you a little bit with, did I include all the things that I wanted to include is if you go here on the site, in the upper right-hand corner, and you go to the contribute button, there's now a new menu item that says preview your operator. And what we mean by that is you can basically upload your CSV and you would basically see how this would pop up at the site. So I can just do that here real quick and upload, Rook Ceph CSV there. And you would see how that would look on the side, right? You see that tile view here, the list view here, and you would also see how the descriptor page would be rendered, right? So that's a nice way to kind of spot any kind of markdown errors or anything that you have forgotten to put in here, as well as if and how your custom resource definitions pop up, if they have proper examples. So that's not only valuable for OperatorHub.io, but can also be used for OpenShift, because the operator hub in OpenShift is visually very close to what we have here on OperatorHub.io. It doesn't display all the data, but displays most of it. So use that as a low-hanging fruit, as a check to see if your CSV is correctly. This would also yield any kind of weird YAML gotchas, formatting errors, indent errors, and whatnot, right? So much better to see it quickly like this than to wait for the pipeline to basically do its thing. And, as I said, that's up here in the upper right-hand corner in contribute and then preview. Another thing that we have starting to put in place and are looking to release fairly soon as a beta, and would really love your feedback on this, is a way to visually edit your CSV, basically starting from scratch, right? So we all know that, coming up with the CSV can be a little bit of a steep hill, even with the examples. Because there are so many fields, and you probably already have your existing Kubernetes manifests, like deployments, service accounts, RBAC, and so on. So what we can do in the next release of OperatorHub.io is basically go into contribute menu again, and there's another item that says package your operator, and that will give you a visual CSV editor. So you've seen I've already uploaded some stuff here, so we can kind of start from scratch. And bear with me, this is a beta version, right? So there might just as well be bugs here. But one thing you can do here is basically upload your existing CSV. Let's take this one. And it would start to pre-populate all the fields in the editor, which are down here. So we basically walk you through all the steps to create a complete and high-quality CSV in this UI. And there's validation on each step as you go. So you see, for instance, here, the cluster service version of Rook Ceph referenced a couple of CRDs, right? And in order to build a valid bundle that you can then submit as a PR, we would also need those CRD files, right? So that's already telling me I'm missing something. So I can basically upload that right away. Don't need to upload this package YAML or the older CSV. And you see it validates that automatically, and it basically also pre-populates the editor with that. So I can now start to go into the editor, look at all the things that I can input there. Maybe I want to change the display name, change the description, the one-liner, as well as the more elaborate description on the main page. So you see here we have a Markdown editor. We give you visually rich previews. Just to make sure you have the right tools at hand to really make your operator look good on both operator hubs. And all of this contains validation, right? So it's much harder to do mistakes here or to miss something. You have visual inputs for almost every aspect of the CSV. you can set your capabilities level. You get an explanation of what that is. So I personally find this much more satisfying and much more guiding than, sitting in front of the YAML editor and trying to think of anything that I could add there. And when you're done with this kind of stuff, you always click all set with operator metadata. And then this is kind of the first section that you've completed. And as such, you would walk through the rest of the editor. So here we would ask you to specify all the CRDs that your operator owns. You would be able to, list those CRDs, edit those, give us the list of resources that are behind, so we are able to populate the UI in OpenShift correctly with this. You would be able to provide us with examples or even spec descriptors to make a custom UI for your operator. So all of this is now much better documented in a much more centralized place, and also always paired with a visual preview of what you're going to get when you submit this. So if I, for instance, miss something here, right? Let's say I'm basically not specifying a name. That would be the error, right? And if I try to run with that, that would also be, kind of sticky in the editor, and it would stubbornly refuse to generate a bundle out of this. So hopefully it's much easier and much more straightforward in the future to create a valid CSV bundle and basically package your already existing operator. Now, we don't want you to start from scratch though, right? And when you don't have a CSV, so what are you going to do then? So one thing we are currently working on is to make this upload feature of the editor also process regular Kubernetes objects like deployments, roles, role binding, service accounts, and CRDs. And we do actually already support CRDs. But what we really want to do is we want to take these standard manifests that probably every operator developer has already because they tested it on their local cluster, and also the standard manifest that the SDK will output, and we will convert as much of that as possible into a CSV. So as all the fields, and you just need to, like it's indicated here, do a review of this, right? Review your deployment. Is that actually what I wanted to do? Take a look at this. Here's my deployment. This is a fully fledged YAML editor, so this will contain syntax highlighting, syntax checks. So hopefully much harder to do, to have errors in the CSV. And yeah, that's pretty much what we're working on right now, and hopefully be able to release that pretty soon as a beta. And yeah, keep being tuned in for that. I think that's all I had. Any questions so far?
I'm not seeing any in the chat at the moment. So thanks for the update. Anyone got questions? If not, shall we move on to the next topic and talk about the Python Operator Sdk? And I think Shawn Hurley is our guest speaker for that.
Yeah, so, yeah, we can talk about it. So as part of this upcoming sprint and releases, the Ansible Operator team has been talked about a POC for a Python-based operator SDK. Basically, how this would eventually work is that you would get a scaffolding from the operator SDK binary, but then you would pull in the dependencies for the actual framework from some of the things from pip, and this would be what we found is a project by a different company and team called KOPF, K-O-P-F, and this project seems really promising, and we're looking at using kind of the work that they've put in to leverage it and to make that a first-class citizen. So we're currently in talks with them, and we're starting down that path to get started on that.
Right. Would it be possible for you to put the link to the KOPF project into the chat for those of us who haven't heard of that one before?
What I personally like about KOPF quite a bit is, the simplicity that it introduces. It's basically single decorator that you put above your function, and that makes the connection to your CRD and basically scaffolds enough code so that your function is executed whenever that event that you describe in your decorator appears. So it's very slick and a very elegant way to basically write custom code in an operator.
How many at the moment, guys? Do we know if of the existing operators are actually written in Python? Is there anything? Are there any Python examples in the hub that anyone's written?
So I know that the team that made the library, they've created a couple of internal ones themselves. I don't think anything has been published externally, and I don't know about anybody else writing anything. Right, you had to basically build out the framework like they ended up doing if you wanted to write one in Python today. It's kind of challenging with the client coming from Kubernetes for lots of different reasons. So you'd have to do all the work that they did. So I highly doubt that somebody has also done all that work and wrote Operator and published it to Operator Hub.
That would probably be the couple of from Zalando. So maybe we can get them to come in and chat one of the upcoming ones. Looks like cool. All right. There is an operator using shell. Oh, that's cool. All right. Any questions for Shawn? Any takers for beta testing it, I guess? Might be the other question. And that'll probably be me, because that's the one language I really do love. So cool.
One thing I'd like to ask the audience is if you see or hear any requests for a Java SDK to write operators.
Yeah, seems to be a popular on the mailing list.
We did just get an issue request in the SDK GitHub for that as well. So there's definitely some interest.
Good. We should expect that at some point. I thought that might be something that was using Quarkus. Is that a possibility?
Yep, I think that's it.
That was who it came in.
I think Quarkus would lend itself very well to that, given how small of a binary it produces and how fast it executes.
All right. So we'll look forward to having that Operator SDK available soon and more Python folks out there. The next thing up is ask Rob to maybe walk us through a little bit of what's coming in Helm 3 release. See if I think was going to get tasks for you, Rob, or maybe Joe.
Yeah, I think Joe is going to talk us through that. He's been looking into some of what the changes in Helm 3 verse 2 look like, especially as in regards to how the SDK uses Helm internally and things like that. So I'll hand it over to Joe.
Perfect.
Perfect. Thanks, Rob. So just put a. Sorry, go ahead, Diane.
You want to share your screen and walk us through?
Sure. I just have a quick doc. Let me see.
Cool.
Works. You all see a doc there?
Yeah, sort of. It's kind of blurry, I have to say, on my screen. Anyone else having?
Yeah, what is that doing?
I've never seen that happen on a screen before. It's like
you may want to restart your screen share, Joe. I don't think.
4 copies of it.
Yeah, that is that actually is a first for Blue Jeans. I know Blue Jeans isn't everybody's favorite, but that was pretty whack. Try that again.
All right, trying again.
If not, I can share it through my screen. Yeah, let me try sharing it my screen.
Okay.
It's not liking you. There. Here we go. Can people see this screen now?
Yeah, if you could zoom in a little bit.
Yeah, view and full screen. Go. There you go.
Perfect.
Take it away. All right.
So as some of you may know, the Operator SDK supports scaffolding Helm operators. So right now, the underlying libraries that the Helm operator uses is all based on Helm 2. So we noticed obviously the announcement of Helm 3 from the Helm guys. This is probably back in May. So they made an initial release of their first alpha. So we've started taking a look to see what exactly that would mean just in general for Helm and also for the Helm operator. So some of the things we noticed off the bat, and we kind of knew about this in advance because some of their docs are up, are that they removed tiller, which has been a big issue for a lot of Helm users because of some of the security ramifications around RBAC and how it handles kind of tiller required kind of this global cluster admin permissions. So they removed that so that I guess basically users of the cluster who had permissions to do the submitting, those permissions would be used rather than tiller's permissions. So that has been a big plus. And then another thing they've done is changed to support namespace scoped release names. So in the past, if you wanted to deploy like a staging namespace and a production namespace and use the same name for your release, that wasn't possible. So that's something that's been fixed in Helm 3. Those two things are already supported by the Helm operator. So the Helm operator, Helm 2 libraries kind of had the flexibility to be able to allow us to make those changes internally to the Helm operator. So those two things are already supported, which is pretty cool. The things that are breaking changes that will cause the Helm operator to need to be upgraded, they have new import paths for their Go library, so that's just a minor change. The big change is there's totally new rewritten libraries around the lifecycle, like the release lifecycle events, so like doing the install, the upgrade, the uninstall. So there'll be a pretty big refactoring there from the Helm operator perspective to support Helm 3's lifecycle events. Probably less related to the Helm operator, but more related to packaging Helm charts. So they've consolidated requirements.yaml into the chart.yaml file. So that's part of like the chart metadata. The requirements.yaml, I think, kind of describes the dependencies of the chart, like what other charts the parent chart depends on, that kind of thing. So that's generally required for packaging a chart. The one impact that might have on the Helm operator is so there's the Operator SDK new -- Helm chart flag. So when we fetch that chart, we also make sure that we fetch all the dependencies. So that'll be a change in how that piece of code needs to work. And then the other change that is not necessarily a breaking change for us, but something that we might need to change on the Helm operator side is that the release name is now required by default, like when you're using the Helm CLI. You can turn that off with a flag that's like -- generate name, but I think the Helm maintainers and the community have basically decided like it makes a lot more sense to let users pick their name rather than have some generated name that really makes no sense in the context of what the release is. So right now, the Helm operator generates a name based on the UUID of the CR that specifies the release. And there's no way to override that right now or configure it from the CR or in the operator source code or anything. So that'll probably be something we're looking at updating in the future to make that more configurable, because I think users will be more likely to want to specify that, because that's what the Helm CLI will start to nudge people towards. There's a couple new features as well in Helm 3 so far. So they've introduced chart values validation using JSON schema. So I think that'll be built into the chart metadata as well. And as you submit values via the CR in the Helm operator, we'll be able to actually validate the values before we actually do the rendering of the release manifest, which will be kind of a nice feature in terms of making sure that what you've submitted in your CR is valid. And potentially we can look at, this isn't something we've gotten to yet, but we could potentially look at including that JSON schema validation as part of an admission validating webhook. which would be pretty cool. So it wouldn't even allow you to create the CR for the release manifest unless that validation passes. And then there's also this new concept of library charts, which also is not necessarily directly related to the Helm operator, but the idea of a library chart is a way to use shared functionality among multiple charts. So library charts don't define release resources, but they can define like shared labels, shared policy in terms of like pod security policies and that kind of thing. So that's a nice thing for enterprises to use to make sure that all of the charts that they deploy in their clusters all have some base level of shared chart templating and policies and that kind of thing.
So just a quick thing on the chart values validation, and we had a bit of a thread going there on the group, the Google group chat, about whether validation logic can be generated or into the CRD. And I guess, wouldn't it be possible to take a JSON schema and kind of convert it to an open API validation schema to put in the CRD, so to have kind of that schema validation even outside of before it even hits Helm?
Yeah, that's a great idea. Actually, that's something we could look at for sure.
Okay.
So other plan changes. So this is just the first alpha. So if you've looked at the Helm 3 planning docs, they've been talking about supporting Lua for templating. So I don't think that'll have a major impact on the Helm operator, other than us just making sure that we're using the Helm 3 library so that we can start supporting the additional templating support that is introduced upstream. So that'll be a nice addition for people to be able to use like an actual programming language rather than just Go templates for their resource templating in their charts. They're also planning, at least talking about, using CRDs for the release metadata and version storage. So right now in Helm 2, and then also in their Helm 3 alpha, they're using secrets, just straight up Kubernetes secrets. And they, the way that it works is it basically encodes the entire release into a big like gzipped protobuf, and then stores that directly as like basically a binary base64 piece of data in the release secret. So I don't know exactly how that's going to change for CRDs, but the plan, at least on paper, is to separate the release metadata from the versions, so that there's like a parent CRD that just talks about like, here's a release and here's the chart that it goes with. And then there's going to be like underlying version resources for each version of the release that is generated. So because this hasn't actually been released, or there's no real source code for it yet, we haven't been able to try it out with how this would look in the Helm operator. Right now, the Helm 2 operator is using kind of a customized version of Helm's release storage. So we'd probably take a look at seeing whether we could do a similar thing for if they switch to CRDs for their backend. So luckily we're able to basically just inherit a lot of what the Helm guys are doing for the release storage. So the idea would be to just keep doing that. Let's see. So we had a discussion with some of the Helm guys a week or two ago around some of the things, basically pitching them like, here's what the Helm operator is, here's some of what our ideas are, and one of the ideas that we've been trying to figure out how to solve. We've solved it in the Helm operator, but there's no solution for this in the Helm CLI. So this idea of like fixing a release. So if a release changes, if the release resources for a release change without the actual release being changed, like being through an upgrade, right now Helm doesn't have a way of reconciling those two things and making sure that the underlying resources stay in sync with the deployed release. So in the Helm operator, we basically have implemented our own code that does this. So whenever a release resource changes, we reconcile the CR. We see, we do like a dry run release manifest. If that hasn't changed from the actual deployed release, then everything's good. But then we can go and make sure that we basically reapply all of the release manifest resources to the existing release. So we had a discussion with them where we're talking about creating a plugin that is called like Helm Fix, for example, that could basically implement that same logic as the Helm CLI and then also in Helm's libraries. So the benefit to us there would be that we could basically lift and shift our logic for doing that reconciliation upstream into the Helm source code so that more of the community could benefit from that. And then we'd get the benefit of having...
Sorry that I keep interrupting. This is really important, right? Because I mean, correct me if I'm wrong here, that there's a big difference between Helm and using the Helm operator in that in Helm, it's kind of a fire and forget, right? You do an install and then you can do an upgrade, but if anything changes behind the curtain, Helm doesn't become aware of it and doesn't do anything about it, right? Whereas the operator, just like you described, will watch all the resources and will then reconcile as needed, right?
Exactly.
So because I keep saying that's a big advantage of having an operator to begin with, that you have this kind of loop, right? This feedback loop that Helm is lacking.
Yeah, exactly. And
this doesn't change that, right?
Nope. So what we're basically pitching is, it seems like more the imperative users of the Helm CLI would probably be pretty interested in this as well, to make sure maybe they could run Helm Fix on some cron job, whatever it is, to make sure that they're basically getting some of the same benefits that the Helm operator provides. So it seems like it's a problem that users of both the Helm operator and the Helm CLI would like to see solved. And the Helm maintainers said the same thing. So the plan is we don't want to impact the Helm 3 release cycle. So the plan is to implement this as a plugin and then experiment and iterate on it, make sure it works well and does what everyone expects. And whenever that gets to a point of maturity that the Helm maintainers are comfortable, then we could introduce that as a built-in subcommand. So yeah, that seems like there was a lot of consensus during our discussion about something that does this sort of thing. So lastly, I kind of probably already mentioned this a little bit, but the big operator impacts are the import paths and basically having to re-implement a lot of the Helm operator reconciler to use the new rewritten Helm libraries. We need to make sure that, so we need to consider, and so A, is it possible, and B, should we maintain backwards compatibility with the previous versions of the Helm operator based on Helm 2? So I think the Helm version 3 is making a pretty good number of backwards compatibility guarantees. So if they're making the same backwards compatibility guarantees, then I think we should be able to as well. But that's something we'll have to kind of look at as Helm 3 progresses. And then also, it's a little bit harder with the Helm operator, because it'd be nice to be able to basically have a user that has existing custom resources for a previous version of the Helm operator to be able to upgrade the operator without having to recreate their existing resources. So there's this migration step that would need to happen potentially. So that's something we'll have to look at when we make the upgrade from Helm 2 to Helm 3 for the Helm operator. Like I said, we need to consider the release name configurability. So because Helm 3 now defaults to requiring a release name, it's something that we expect more users to ask for, since right now the Helm operator doesn't support customizing the release name. And then we're going to so we also have this other kind of orthogonal task to be able to make improvements for Helm operator or hybrid operator developers. So if you're not sure what that concept is, that's basically enabling operator developers that have started out with a Helm operator that want to now do more customizations and move to a Go-based operator that includes a lot of the Helm operator reconcilers and functionality. So right now, if you were to run like Helm migrate, you would see that the main function that gets generated for the new Go operator that uses Helm basically has no way to customize anything. So we've been talking about how can we open that up, make more of a library out of the Helm operator controller, and then giving Go operator, basically these hybrid Go Helm operator developers, the ability to customize more things about their Helm operator. So some examples of that would be So one of the examples that's actually an open issue right now in our GitHub is I want to basically have a mapping between the CR spec and my Helm values. So right now we basically take the CR spec verbatim and put that directly in as the Helm values. So there's a question like, can I have like a mapping function that converts my CR spec to a separate set of Helm values? And kind of the use case there is I've got 3 different charts that I want to create. Basically, I've got a parent chart with like 2 or 3 subcharts, and they all need like one value to be in 4 different. They need like one key, let's say like a username, to be in all 4 charts in different that use different names for that value. If that makes sense. So like the parent chart might have like database.name, and some of the subcharts might have like web app.database.name and that kind of thing. So it's basically a way to make it easy to use just one value that gets propagated through all the different charts in the way that it makes sense for that value. So that's an example of why we would want to improve the Helm hybrid operator experience. There's other things like being able to have like a custom function for setting a release name, having better control of like pre and post install and upgrade chart hooks. So like right now in Helm 2, you can specify like a separate set of templates for pre and post install and upgrade lifecycle events. But there's been users that have said, hey, it'd be really nice if I can run my own custom Go code in the same scenario, which would make the Helm operator a lot more robust in terms of being able to do some of the higher level operator maturity kind of things that the Ansible and Go operators are already capable of. That would be a pretty cool thing to add. The reason I'm talking about all this is because a lot of this will change depending on whether we do it in Helm 2 or Helm 3. So we're likely going to wait until Helm 3 is released before we make a lot of these big breaking changes. So the last little section here, there's just a couple of issues that I opened in the Helm repo about things that I've noticed that aren't quite supported that we currently are able to do well. So one is the custom rendering engine that's supported in Helm 2 is basically not supported right now in Helm 3. And the reason we use that is to be able to inject owner references into all of the resources that are created from like in the chart release manifest. So that's not like a huge deal because we still have this finalizer in the Helm operator to be able to do the uninstall process, which clears things out. But if there's something that goes wrong with that and that fails for some reason and there's a bug somehow in the Helm operator that prevents the failure logic to occur, there's this backup of having, it's nice to have garbage collection enabled for all of these things such that if the parent CR goes away somehow, all the underlying resources can get cleaned up. So there's a discussion going on about whether they'll re-add support for that or not. I think they made this was like a conscious decision that they made. So I think they need to think about reevaluating that decision, and maybe they will, or maybe they won't. So we'll see how that goes. And then right now there's like this weird situation with handling values where like we have to write values out to a file and then load them back in using the Helm CLI. There's like this coupling between the Helm CLI library and then the underlying like Helm SDK libraries that there's an open issue out as well to have them look at a better decoupling between those two things so that we don't have to, basically such that we can take our values directly from the spec and hand them off to Helm. But yeah, I think that's about it. Are there any other comments, questions?
I guess I'm very interested in where you talk about hybrid operators, right? And we can take that offline maybe in the Google group chat, right? Because I've been thinking, well, we have a lot of Helm charts, right? And so we thought, okay, we can start with the Helm operator, but what the Helm charts do not give us is what we call day 2 operations. So we thought, okay, for let's just say backup and restore or something like that. So we were thinking, okay, how can I now add that in? And I was thinking it should be relatively easy to capture that maybe in a separate CRD and in a separate controller, but then add that to the same operator, right? And that would effectively be a hybrid operator with fairly little dependencies between the two controllers, so to speak. One could be Helm based on the Helm operator, and one could be, written in Go from scratch or written in whatever other language, right? Is there anything technically that would make that hard or impossible to do?
No, I don't think so. I think you could really do that right now if you wanted to. If you look at the migrate command, if you run like Helm or Operator Sdk migrate in an existing Helm project, it'll convert your project to a Go project, and then you'll get like this main file that right now has like this very bare bones. Basically, it calls like helm.run. If you go and look at that helm.run, that's basically what a main file looks like for a normal Go operator. So what you could do right now, in fact, is take the contents of that helm.run and put it in your own main.go, and then add your own other APIs and controllers and that kind of thing into that main.go. The one caution I would have is right now that's not very exposed, so we will likely be changing that, especially with the Helm 3 stuff. So don't expect there to be a lot of those. Basically, don't expect that thing to be backwards compatible. We're probably going to change a lot of that in the future.
Okay, yeah, that makes sense. And like I said, I've been mostly thinking, and I have to admit we've never done this, right, of adding new controllers for additional functions and then basically exposing them in separate CRDs, but then having them bundled into one operator.
Yep, that's definitely possible, like already with a Go operator. You can also do that with the Helm operator just by having, multiple charts. But so far, I haven't heard anyone we haven't seen any issues or anything for people who have combined like the Helm operator controller with like their own custom controller. But that's definitely possible. You just have to go to a little bit more effort to get all the code working. The SDK migrate command doesn't make that super easy yet, but it should be possible.
Okay. Yeah, and I guess as soon as we get around to try exploring some of that, we could even bring it back to this call and kind of share what we've learned.
Absolutely, that'd be great.
I do have a question on the existing out-of-the-box Helm operator. Does it support multiple Helm charts?
So yes. So it depends on what you mean, but you can do two things. One, you can have a single operator. You have multiple. If you look at the watches.yaml file that gets created, you can basically add multiple charts, like top-level charts, into the Helm charts directory, and then define multiple watches in the watches.yaml file. So that's if you have like multiple CRDs that you want to define. So that's supported. The other thing that you can do is you can have like one chart that has a bunch of subcharts, and all of that works, out of the box, no problem, in terms of the parent chart templating out the entire release manifest based on all of its subcharts.
So in the first scenario where you have multiple charts and multiple watch, is it possible to also have a single CRD or CR?
No. So in the first scenario, you'd have each chart would have its own CR associated with it. This has come up at least once or twice as an issue in our GitHub, I think, so you could probably search for it, and I can try to search for it too. The suggestion I made was basically if you wanted to do something like that, you could basically have one chart that basically uses all of the other charts that you wanted to use as a parent chart, and then just use one CR via that parent chart. There's some gotchas and caveats with that, but depending on depending on your use case, like that's a way to do that.
Yeah, I'm trying to take a look at different options here, and ideally what we're trying to do is share global values across those charts, and trying to have a single CR that supports that.
Yeah, so I think that's the kind of the use case I was describing for the mapping a CR set of values to like a whole bunch of different chart values, and that's one of the kind of the caveats that I would mention is like, if you have, so the way I would suggest is like, okay, you're going to have one parent chart that has a bunch of subcharts for all of the actual things that you want to deploy under that CR. The problem with that is that if each of those subcharts has a different value key for like a value that you want to define once in your CR, like that's not possible right now. So you have to define it in multiple places for each subchart. And that's not a great user experience, and it's not easy to validate and that kind of thing. So that's definitely one of the use cases for the Helm hybrid operator. And that's not even, like right now, it's not really even supported if you tried to use the Helm reconcilers right now. So that would be a problem. You can't really do that at the moment.
Okay, thank you.
Yep.
All right then. I think we're close to wrapping up here. So I just want to be respectful of people's times. I was going to mention one other thing. In the notes, you'll see I'm trying to arrange at Helm Summit in Amsterdam to do a Helm operator hands-on workshop, and I was wondering if anyone else on this call was planning on going to Helm Summit or had submitted talks to Helm Summit, so that we could host and have a few more bodies in the room for the hands-on workshop. We always need more attendees and more proctors as well. So anyone's planning on going there?
We have submitted, I mean, within my team, we submitted 3. We haven't heard back yet, but I assume we'll have a couple of people there, and I would definitely want to support having them in this workshop as well.
Okay, great, Andre. So I'll reach out to you. Matt Dorn, who's on the call as well, is usually the person I rope into doing the teaching, and I think Daniel Messier also submitted a talk or 2. So hopefully we can bring more people up to speed and on board with the Helm operator work. So thanks, Joe, for the update. And I'm looking to see our next meeting will be the 3rd Tuesday in July. So if you have a topic that you want to talk about, or that we should be talking about that we didn't, or an operator, hopefully what would be wonderful is if we had an operator, will be the 16th of July. So if you have something that you'd like to talk about, just let me know or Rob know, and we'll add you to the schedule.
Yeah, thanks everyone for joining us at our new time. We're going to try to get a Google invite sent out to the entire group. We ran into some issues, and I saw Google Calendar was down this morning, so it wouldn't have helped. But hopefully this time works out for everybody, and we'll get some more participation from folks where this typically would have been their Friday evening. Now will be in the middle of their week at least.
And there is one last question, and I will stay on if someone can answer Mansur's question. He's asking, currently we have to put our charts into Helm Operator. Is it possible to enable for Helm Operator to download it from Report Helm repo? And Joe was saying, yes, you can do that. So Mansur, if you, in the gist, put in your full name, because I don't have it, and maybe an email contact, we can hook you up, and Joe and you can correspond either there or on the Google group and ask that question and get that out in the public. All right, check out the Helm user guide in our GitHub. All right, thank you everybody for joining. I'm gonna post the full recording to the playlist in YouTube, and I will snip up the different updates into little short ones for other people to read too. So look for that in our YouTube, and that's the end of our hour. Take care, guys.
Thanks, everyone.
Bye, thank you.
Cheers, guys.